Hello, this is iMathit with Samuel Oke, and in today's lesson, we are going to be solving a exact differential equation. So, I will be showing you how to solve an exact differential equation. So, when you look closely into the two differential equation we have on the chalkboard here, you will notice that it has composed function cos xy in it. So, it will be a bit difficult for us to simply separate the variable, so to obtain the original function that yield this differential equation. So if you are familiar with how to find the total differential of a function, so what we are about to do right now is we are going to be working it backward from the differential equation to the original function. So the first thing we do is we write the equation in the form Mdx+Ndy equals 0. If it is not already in the form. In this case, it is already in the form. So let's go on and carry out the test if the equation is exact. So the equation will be exact if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to s. Okay, so let's do that. So I'm going to set m is equal to cos x plus y. As you can see from the equation. And n is also equal to 3y squared plus 2y and plus cos x plus y. Okay? Now let's find the partial derivative of m with respect to y. So what's the partial derivative of cos x plus y with respect to y? That will be negative sine x plus y. And what is the partial derivative of, mind you, we are finding the partial derivative with respect to y. What is the partial derivative of n with respect to s? So look in here, 3y squared is a constant, right? Because it does not have x in it. 2y as well. So we have cos x plus y to deal with. And the partial derivative of cos sy with respect to x is going to be negative sine x plus y, right? And you will see that partial derivative of m with respect to y is equal to the partial derivative of n with respect to s. So the differential equation is exact. So we can go on and use the method. So the original function u that yield the differential equation is equal to the integral of m with respect to s and plus k, right? A k of y, a function of y, not a constant of integration, don't forget. So that would be the, we are to evaluate the integral of cos x plus y with respect to s and plus k. So what is the integral of cos x plus y with respect to x? So that's going to be sine x plus y, right? And plus k. So we are left with one problem now to find k, right? So that would give us the function u. So let us find the derivative of u with respect to y this time. So what is the derivative of sine x plus y with respect to y? That's going to be cos x plus y. And plus the derivative of k is the k dy, right? Good. The next thing we do is let us bring n side by side with it so that we can compare. N also has cos x plus y in it. So I'm writing it first. And it has plus 3y squared and plus 2y so that we can easily compare. At this point, you will see that the k dy is equal to 3y squared and plus 2y. You may need to go back and learn how to obtain total differential so that you get this process very well. So if you are still having any problem with it. So we multiply both sides by dy and we integrate both sides. And k is going to be equal to, there was the integral of 3y. That's going to be 3y raised to power 2, 3, right? Y raised to power 2 plus 1. That will be y raised to power 3 and divided by 3. And plus 2y raised to power 2 and divided by 2. Okay? So, and that reduced to y raised to power 3 plus y raised to power 2. And this is the function k. So let us simply go on and put that there. So the function u of x comma y, that the differential equation is sine x plus y and plus y raised to power 3 plus y raised to power 2, which is equal to 0. And there you have it. So what have we done here? Let's really go back through the process. the first thing we did is we rewrite the equation in form Mdx plus Ndy. In this case, it's already in the form. Now we still go on and carry out the test to see if this method will apply by checking if partial m partial y is equal to partial n partial x. Now we set m and n respectively, and we find their partial derivative accordingly. So, and we find that the partial derivatives are equal, so we know that the differential equation is exact. So we set the function u, which is equal to the integral of Mdx plus k. We find that, and it gives us sin x plus y plus k. So now to find k, we simply go on and find the derivative of u with respect to y. So we obtain that, and we compare that to n. So we found that the k dy is equal to 3y squared plus 2y. So we evaluate that, and we obtain k. Then we put it back in u, and that's it. So we'll come back on this channel to see more lessons on other types of differential equation. Hit the like button, please. And until next time, please keep mathing it and keep winning.